are going to learn some fundamental concepts related to operating system and programming, including user mode, kernel mode, system calls, compilers, interpreters, and the Java virtual machine. These are important for both software development and understanding how programs interact with operating system. Let's get started. This session will cover the difference between the user mode and the kernel mode in an operating system, and what system calls are and why they are needed. And we'll learn how what's the difference between a compiler and an interpreter in the programming, and what is a Java virtual machine and how it works. By the end, you'll have a clear understanding of these concepts. Coming to user mode versus kernel mode. What to say? Computers have two important modes of operation: user mode and kernel mode. User mode is where normal applications run. It has restricted access to system resources to prevent accidental crashes. Whereas kernel mode is where the operating system operates. It has full control over the hardware and the system. For example, let's say when you open Google Chrome, it runs in user mode. When Chrome needs internet access, it requires the OS, which switches to kernel mode to handle the requests securely. Here, the user mode contains applications like browsers, media players, and text editors, and the kernel mode manages the core OS functions like memory management and hardware control. When a program needs system resources, it switches from user mode to kernel mode using a system call. Here, the picture you can see that how the user mode and kernel mode are connected. It shows how applications communicate with the OS through the Windows API, and which connects to user mode drivers, kernel mode drivers, and file system drivers to access the hardware resources via the hardware abstraction layer. This is all about this picture. And coming to the next slide, what is a system call? A system call is like asking permission from the OS. Users User applications cannot directly access hardware, right? So they make a system call. The OS checks if it's a valid request and then executes in the kernel mode. For example, say when you save a file, the program asks the OS through a system call, right? The OS handles the request and writes data to the disk. And here you can see a clear picture of what system call diagram. A user application requests a service like reading a file. The request is sent to the OS through a system call. The OS executes the request in the kernel mode. The result is returned to the user mode application. This is all about that. That means how a system call transits between user mode and kernel mode. When a user process when a user process needs privileged operations, it makes a system call, triggering a mode switch bit equals to 0 to kernel mode. When the OS executes the request, after execution, control returns to user mode, bit equals to 1 to continue normal execution. This is all about the picture. And next, coming to what is a compiler. I think everyone are familiar with compiler and interpreter. But let me give you a clear picture what it is. Compiler translates the entire source code into machine code before execution. It makes execution fast because everything is pre-converted. But compiling takes more time initially. For example, in C or C++, you write the code and then a compiler like a GCC and then run a compiler like GCC. The compiler translates into a machine executable file like a .exe or .out. Coming to interpreter. Interpreter translates code line by line at runtime, unlike the compiler. This makes debugging easier since error stops execution immediately. But it's slower because translation happens while running. For example, Python runs using an interpreter Python file. .py. It reads and executes the code one line at a time. Coming to the comparison between the interpreter and the compiler. Here, coming to translation, compiler takes a full code at once, and interpreter takes line by line. And it's faster execution in compiler compared to the interpreter. And debugging is easier in interpreter, whereas it's harder in compiler. Examples of compiler C, C++, and interpreter are Python and JavaScript. If speed is important, use a compiler. If debugging is important, use an interpreter. What is JVM? JVM is a Java virtual machine. Uses a special approach here. Java uses a special approach called this JVM. Instead of compiling directly machine code, Java first compiles into bytecode. This bytecode can run on any OS that have a JVM installed. That's why Java is called write once and run anywhere. If you write a Java program on Windows, you can run it on Linux without any changes. Here coming to the JVM architecture, first the Java code compiled to the bytecode and this given to the JVM, not to the OS directly, but JVM will be giving. The JVM converts the bytecode into machine code that the OS can understand. And this is about the JVM, like Java code is written by the programmer and it converts into the bytecode by JDK, and JVM along with JIT, just in time compiler translates bytecode into machine code which the hardware executes. This is what the picture depicts. And next, coming to the overall conclusion of this video. To summarize, user mode versus kernel mode. User mode is for applications and kernel mode is for OS functions. And the system calls is a bridge that is that between the applications and the OS. In compiler versus interpreter, compilers are fast but takes time to compile. Interpreters are slow but easy to debug. JVM. JVM converts Java bytecode into machine code, making Java platform independent. And thank you for watching. I hope you found this session helpful. If you have any questions, feel free to ask in the comments. Don't forget to like, share, and subscribe. Thank you.